So good evening everyone. So let's start our new chapter. So if you are unable to see the videos, please inform me. Kanit, can you able to see now? Kanit. Okay. So let's start the chapter called as circles. So in the previous classes we have studied about the circles. Circle can be drawn without any curved shape, which is a closed figure. Generally we know about it, that is called as circle. So what is the how to draw a circle, which is very important. How we are going to draw the circle and how we are going to do all the problems which are related to the circle, that is also most important. Yes. Yes. So please stay focused towards the subject. So how much it is possible, that much I'll try to complete. Yes. Let's define first what is meant by circle. First we will write the definition of circle. So what is meant by circle? In easy method, how we are going to write the definition of the circle. Circle is a collection of points. For example, if you are taking the points like this, it is a collection of points which is equidistance from a fixed point, that is called as from the center point. If you draw the radius and the circle like this, which forms a circle in the easy method. Yes. So what we'll write for the circle definition: a set of all points in a plane which is equidistant from a fixed point, that is called as circles. I think we are already having the definitions. You can go through where we already written in our notebooks all the definitions. You can go through the notebook also. You can keep the notebook along with you. So those who are having notebooks, you keep the notebooks along with you. First we are going to write about the circle, a set of points which is equidistant from a fixed point, that is called as circles. Or you can write a circle is a collection of points in a plane which is a equidistant from a fixed point on a plane, that is called a circle. Next we know about the radius. What is meant by radius? The distance from the point, the distance from the center of point center of a point on the circle, which is called as radius. So general circle, this is called as a radius. So this we will call it as okay. Next we will write the diameter. Diameter, what is called as diameter? So 2 points, 2 points joining the circle, passes through the center of the point, passes through the center of point, that is called as diameter. So this is circle, for example this is circle, this is the center O, so which passes through the point AB, that is called as diameter. Next we'll write all the definitions right over here only. What is meant by circumference and what is meant by tangent, what is meant by secant. Next we'll write the definition called as circumference. Circumference, what is meant by circumference? Circumference is nothing but the, what is circumference? The boundaries of a circle is called, the boundaries of a circle is called circumference of a circle. Circumference. So if it is circle, the boundary, you see this one, so this is called as circumference of a circle. Is circumference of a circle formula is 2 pi r. So that is called as circumference of a circle. So next we'll go for the remaining all the definitions. I'll write in a sequence. The first we'll call this as chord. What is meant by chord, which is very important. So 2 points joining the circle from one point to another point, one point to another point without passing through the center, passing through the center, that is called as chord. For example, if you draw the circle, this is the center of the radius and we are having one more radius which forms the diameter. So here if I am drawing any 2 points A and B, here P, Q, so it is not fixed that we have to draw like this only shape, but it should not pass us through the center of the circle, that is called as chord. Already we studied about the diameter. Next, so what is meant by arc? Arc is nothing but an arc is a part of a circle, part of a circle. So draw the circle. So if you see, this is the center of the circle. So how to do? See, if I am taking any 2 points, for example P and Q, these are the 2 points which I am taking on the circle. So this is called as the arc, that is called as the arc. Now after arc we have to know about the sector. What is meant by sector and what is meant by segment? Sector is nothing but the angle which is formed by the angle which is formed by the which is formed by the chord, which is formed between radii and arc of the circle. Arc of a circle, that is called as sector. So how to find out sector? See, this is the circle. If you draw one line from the center of the circle, a point on the circle, that is called as radius. If you draw more than one point, that is called as radii. If you draw the center point to the point on circle which is equidistant, that is called as radius. More than one point, it is called as radii. Now you see this one, P, Q and O. So very simple. The angle which here the angle is formed, the angle which is formed between the radii, these are the two lines which is called as radii, and this is the P comma Q is called as the arc. So this is called as sector. So this is called as minor sector, and the remaining part is called as major sector. Next one is segment. Segment is also same. The area, so not the area, this is not angle, the area enclosed. The area enclosed between the radii and arc of a circle is called sector. The area which is enclosed between chord and arc. Chord and arc is called as segment. So circle, and this one is the, I am taking the point A and B, and this is the center of the circle radius. So now you see, this is the arc, AB is the arc and this is the chord. So this is called as minor segment, and this one is called as major segment. These are formulas generally we have to, which we are using. See, this chord, arc, sector and segment, which we are using in the next area related to circle chapter. Now the main important two topics are tangent as well as secant. So what is mean by tangent and what is mean by secant, that we have to learn now. Now see, I am going to write the definition of the tangent. What is mean by tangent? Tangent is nothing but a line which touches the circle at a point is called tangent. Very simple. This is a circle, a line which is touching the circle at point like this or like this or like this. So this is called as tangent. That's it. A line which touches the circle at a point is called tangent. What is meant by secant? What is meant by secant? Secant is a line which is passes through the circle, which is passing through the circle, touches at 2 points, touches at 2 points is called secant. For example, like this is a point A, this is a point B, or like this A or B, or like this A and B. So this is called as secant. So this is called a tangent and this is called as secant. Theorems also tangent. The straight line touches the circle at 1 point. So next we are going to do the there are two theorems which are very very important in the exercise, that I will explain first. So first I will write the first theorem. I think this place is not sufficient. There we can do any problem. Now see the first theorem. So theorem number 1. What is given? The length of a tangent drawn from an external tangents, length of a tangent drawn from an external point to a circle are equal. Circle are equal. Now see how we are going to prove this theorem. That is the most important thing. I think everyone can able to see the video. So if you have any glitches, please inform me. Now see. First, let us understand the theorem statement first. See, length. Length is meant by one line of a tangent. Tangents. It's not tangent, tangents. If you draw one line, that is called as tangent. If you draw more than one line, that is called as tangents. Drawn from external point to a circle are equal. Very simple. See, this is the circle I am taking. It is not exact circle. Yes. So this is the center point. The length of the tangent. See, from here I am drawing a line. This is one tangent. Okay. And from here we are taking another line. This is one tangent. Two tangents done. Yes, this is the tangents. Now see, when you are drawing a line from the tangent, one tangent and another tangent, these two tangents are intersecting in an external point. This is the external point. This point we are taking as P. This point we are taking as Q. This point I am taking as A, R. Okay. Now see, two tangents which are drawn from an external point to a circle. We have to show that PQ and PR line are equal. That's it. See, now I am joining OQ. If you draw one central point to the point on circle, that is called as radius. More than one point, it is called as radii. Now we are joining P and O. Now see, first we have to write the statement what is given. Given, see I am writing the proof. Given O is the center of a circle. O is the center of circle with two tangents. That is already given. Two tangents. PQ and PR. To prove, what we have to prove? To prove PQ is equals to PR, we have to prove. That's it. PQ is equals to PR, we have to prove. Now see what we are going to do. Now see, I am joining OQ, OP and OR. Now from center of circle to the tangents joining at the points Q and R, center of circle O, and from center to external point, that is P. So we are joining the three. One is OQ, OP, OR. So these are the three lines we drawn. Now see what we wrote here. Angle PQO is equals to angle PRO. PQ and PRO. We are writing what we are writing. PQO and PRO. Why we are joining this one? See, this is the radius of the circle. This is also a radius of the circle. This radius of the circle is perpendicular to the tangent. That means radii, see, from the center of the circle to the point R, and PR is a perpendicular tangent. From O to Q, it is a radius, and PQ is a tangent. That means the radius is perpendicular to the tangent. Radii is perpendicular to tangents. Now see, in triangle PQO and triangle PRO, when you are comparing the two triangles, what we are going to write? Very simple. See, PQO is one triangle, PRO is another triangle. According to these two triangles, what I am write? PO is equals to PO, which is the common side. OQ is equals to OR, radii of same circle. OP, OQ and OQ. Okay, I will tell. See from the center of the circle O to the tangents. From one tangent is at Q point, one tangent is at R point, and from the center of the circle to the external point we are joining. That's it. So OQ, OP and OR is done. This is OQ after joining OR and OP. Now see, angle POQ, angle PROQ, both are radii is perpendicular to the tangent. If you draw one line, that becomes radius. Radius is perpendicular to tangent. For example, how we have to draw? See, if this is circle, this is a radius. For example, this is the tangent. That's it. Why? Because tangent touching at one point is called, so tangent means the line which is touching at one point, that is called as tangent. Now see, the final, last and final, what you are going to write? Angle PQO is equals to angle PRO. See, PQO and PRO both are making the each angle how much? Each 90 degrees. Therefore, triangle PQO is similar to triangle PRO by CPCT, by corresponding parts of congruent triangles, by corresponding parts of congruent triangles. PQ is equals to PR. PQ is equals to PR. So now go through this theorem. I think if you have in the question also you can see once again. Very simple. What is again? Length of the tangent drawn from an external point to a circle are equal. See, we are drawing the two tangents. The two tangents are connecting at external point. We have to show that PQ tangent and PR tangent both are equal. Now what we are writing already, which is given, O is the center of the circle with the two tangents. One tangent is PQ, second tangent is PR. Now in the theorem what we have to prove? PQ is equals to PR we have to. For that sake, first we are taking the center of the circle, that is O, and we are joining the tangent OQ and OR, OQ and OR, as well as the center of the circle to the external point OP. There is the below. These sentences, it is not mandatory to write as it is. You can write your own sentences also. Now see, PQO and PRO. See, OQ is one radius, OR is second radius. These two radius generally will write it as radii. Now see, PQO and PRO both are radius is perpendicular to the tangent. See, OQ, as I said, this is the radius and this is the tangent. Both are perpendicular to each other. Here OQ is the radius, PQ is a tangent. Both are perpendicular to each other. Now we are taking the two triangles. One triangle is PQO, one triangle is PR. See, OP, which is the common side for PQO, OP, which is common side for PRO also. Next, OQ is equals to OR. Why? Because OQ is one radius, OR is one radius. These two radius are inside the circle. That's why we wrote radius of the same circle. Lastly, PQO and PRO. See, wherever you draw the tangent, there makes an angle 90 degrees compulsory. Next, therefore triangle PQO is similar to triangle PRO by corresponding parts of congruent triangles. PQ is equals to PR. That's it. So by RHS congruence, this Why? Because why we are writing only RHS means we are writing right angle triangle perpendicular. Sorry, why we are writing RHS means here tangent radius is perpendicular to the perpendicular. Perpendicular means 90 degrees. 90 degrees where you get right angle triangle. Okay, this one compulsory you have to write, but by RHS congruence, mandatory to write by RHS congruence, triangle PQY is congruent to PRO. Yes, so please note it down, those are writing. Now we can go for the next problem. So if the theorems will be done, the problems, all the 9 problems at a time I'm going to explain. If it is possible, now I will explain. Otherwise, the schedule will be done by tomorrow morning or tomorrow evening session. Please teach someone. Vandana, she is telling to teach integration. So whenever it is needed, necessary, so definitely I am going to teach integration also. Differentiation and integration also. Definitely I am going to teach compulsory. No need to worry about it. Yes. Now we go for the second theorem. Theorem number 2. These two theorems which we are going to use in the problems compulsory. Now see the second theorem. So theorem number 2. The tangent at any point on a circle, the tangent at any point on a circle is perpendicular to the radius through point of contact. Radius through point of contact. See the tangent at any point on a circle. Here the tangent at any point on a circle is perpendicular to the radius of the point of contact. Very simple. See, this is the circle and this is the radius point. Which point? So this is called as tangent. So tangent line we are taking as x and y. This is the point, center point we are taking O and P. Now see, the tangent at any point on a circle perpendicular radius of the point of contact. So for example, now we are doing the proof. Given that, first what is given? Tangent touching the circle at a point. Given that xy is a tangent touching the circle at a point P. So now what we have to prove? We have to prove that OP is less than XY. We have to prove. That's it. OP, point of contact. Now we have to show that OP is perpendicular to OP is less than XY. This is also very easy theorem. We can learn very easy method. Now see, from the center of the circle, see carefully. From the center of the triangle, I am drawing an external point 1 like this. If I am taking an external point N, see carefully, I am taking from the center of the circle, we are taking an external point. Now see, while the center of the circle going to the external point, this center of the circle line should compulsory passes through the circle point. There I am taking the point as M. If OP will become the radius, OM also will become the radius. A straight line which touches the circle at any point is tangent. See, from the center O we are drawing an external point. That external point, when you are joining from the center of the circle, that circle line which is passes through the center, which compulsory intersect on the circle, then passes to the external point. If OP is the radius of the circle, then OM is also a radius. Why? Because in the circle, the points which are equidistant in from the points which are equidistant from the center of the circle, sorry, from the center of a point to the circle. Now see, from the center of circle joining the external point on the tangent. On the tangent only we are taking some external point. That means O to N. N. Now see, OP is equals to OM. That means radii of same circle. Radii of same circle. See, very simple. The tangent at any point on a circle. This is the tangent. Wherever we'll take a tangent on the circle to the radius through the point of, we have to show that very simple method. We have to show that tangent is bigger than the radius of the circle. That's it. Simple method. Tangent which is bigger than the radius of the circle. For that we are taking xy as a tangent touching the circle point at P. What we have to prove that OP is less than xy. Now from the center of the point joining the external point on the tangent O to N. So OP is equals to OM. Why? Because whenever you are taking an external point from the center of the circle, it should passes through the circle. That circle we are taking point as OM equals to N, which is the radius of the same circle. Now what we are right? See, this is the radius and this is the external point. Now see, ON which is bigger than OM. ON bigger than OM. That means OM is less than ON. Yes. Yes. The since OP is the smallest, I can write in place of OP, can write ON also. OP is less than ON. In place of OM, I can write OP also. See, OP is the smallest distance of a circle, smallest radius, you can take radius of the circle comparing to tangent. Comparing to, so how we got this one smaller means, see, when you are passing the point center of the point to the external point, which is, while it is passing exactly on the circle, we are getting a point that is called as the radius. If you see this one, see these are the two radii. So if you take the external point ON is bigger than OM. Here radius OP and OM both are equal. OM less than ON, OP less than ON. That's it. Tangent of a circle. That means this one again writing here, that is OP is less than ON. So therefore OP is perpendicular to the tangent xy. Therefore OP is less than xy. That's it. Now we'll go for the test tube questions. If it is possible, I'll try to come in the morning session only tomorrow. Let me complete few problems. Yes. Now we'll start the problems. I'll show you some of the problems. How to do. Maximum you'll get the same method problems compulsory. I'll show the question directly in the textbook itself. And we are having one more theorem also, which is related to tomorrow morning, maybe after 10 a.m. Maybe at any time, but after 10 a.m. I'm going to start the class compulsory. All the problems I'll explain. I'll try to after 10 a.m. It may be any time. I also don't know exactly at which time I'm going to explain, but definitely I'm going to come in the morning session only. Yes. Now we'll go back to the problems. Circles. Yes, circles we are having starting a very small problems. We are having some of the fill in the blanks. A tangent to a circle intersected in dash points. Tangent which intersected one point. A line which is passing through the center of the circle is called secant. A circle having dash parallel tangents, two parallel tangents. The common point of a tangent to the circle and the circle is called point of contact. So now we are going to do the first question, which is given in the question, textbook question. A tangent PQ at a point P. Now first I'll show the question. So then I can able to draw this question solutions clearly. Now see the question clearly. What is the question given? A tangent PQ is a line which is passes through the center of the circle. Passes through the center of the circle. A tangent PQ at a point P of a circle of radius 5 centimeters meets a line through the center at point O and a Q and OQ. We have to find out the length of PQ. We have to find out. That means we have to find out the tangent. We have to find out the tangent. Very simple. Now see how we are going to draw this one. See, this is a circle and this is the radius is given 5 centimeters. Okay, and the line from the center of the circle is given as 12 centimeters. Now we have to find out, yes, sorry, so we have to draw the point like this and we have to find out the center of the circle. We have to find out the see, if you draw the circle like this, so exactly you are going to get the right angle triangle. That means this becomes the opposite side, this becomes the hypotenuse, this becomes the adjacent side. If you're going to write the points P, O and Q, we have to find out the length of P. So given length of OP, that means adjacent side according to our 5 centimeters. Next, what is given? That means length of OQ, length given length from center to external point. That means OQ is equals to 12 centimeters. Next, radius of the circle. OP is equals to 5 centimeters. So if you see this triangle carefully and observe it, I think you are unable to see the diagram. Yes, if you see the diagram properly, here we are getting the right angle, here we are getting the angle. So opposite by hypotenuse we are getting, opposite hypotenuse and adjacent sides we are getting. Yes, now come back to the class. Yes, listen here. That means hypotenuse whole square is equal to opposite whole square plus adjacent whole square. What is the hypotenuse is given? OQ whole square is equals to OP whole square plus PQ whole square. However, write additions, nothing will happen. Okay, OQ means 12 centimeter whole square is equal to, we have to find out 5 centimeter whole square plus PQ whole square. You have to find out 12 square is 144 centimeter square is equals to 25 centimeter square plus PQ whole square. Bring this to left hand side. So PQ whole square, what we can write? 144 centimeter square minus 25 centimeter square. So PQ whole square is equals to, we are getting 119 centimeter square. When square goes right hand side becomes root 109 centimeter square can be written as PQ value you are getting root 119 centimeter. Like this you are going to get the maximum MCQ 1 mark. It is possible of getting MCQ 1 mark question compulsory. So please note it down everyone. No, not yet. Tomorrow morning I am going to prepare the question paper. I didn't made question paper yet now. Okay. Now see what is given. Question number 4. Question number 4 is very easy. Draw a circle and two lines parallel to a given line such that one is a tangent and other should be a secant. Draw a circle and two lines parallel to a given line such that one should be tangent and one should be the secant. Very simple. See, this is the circle for thing. If a line is given, already line is given. For example, if we are taking this one as the external line completely, A and B. Okay. If you want to draw the parallel to the two lines, I am drawing a line. This point I am taking as CD. This is the tangent and which is parallel to the external line. And second one also we are drawing one more line that is called as D, E and F. This is called as secant. Now you got the point. See what is given the question. We have to draw a circle and two lines that should be parallel to a given line. For example, this is the circle and this is the totally external outside line. So the tangent should be parallel to the external line which is outside the circle, outside which is not connected. Tangent should be parallel to the external line and secant also should be parallel to the external line. So this is about the fourth question. I think now you understand how to draw the tangent, how to draw the secant. Very easy method. Now see. So we are going for the next exercise, that is 10.2. 2. Now here also same like this kind of question, one question is given. I'll show that question also clearly to you. Yes, now I'll do the problem. Let me start some of the problems. There are, I think, 4 to 13 9 theorems are there that I'll explain. Maximum it it doesn't take time now. Tomorrow morning session only I can able to explain that problems. Okay. Now see the question. From a point Q, the length of a tangent to the circle is 24 centimeters. See, this is the circle and this is the center of the point. If you take a point like this is the tangent. Now see, the length of a tangent from the external point. This is the tangent. If I am going to draw like this, so this is given 24 centimeters. Now see what is given, and the distance of the point P from the center, the distance of Q from the center is, so this is the tangent from an external point is Q, and they are taking as T from the center of the circle. If we are taking the line, so this line, what do you call, yes, this is given 25 centimeters and this is 20. We have to find out the radius, so I'm taking this point. So if you want, I'll draw once again the diagram. See carefully. This is the circle and this is the center of the circle and this is the radius, and the external point is 25 centimeters and the tangent, yes, so this is 25 centimeters and this is 24 centimeters. This is the radius. I'm taking as T, O and Q. Now see what we are going to write. We have to find out the radius. So given that, I'm writing, given that the tangent QT is equals to 24 centimeters, so it is a hypotenuse, this one is the opposite and this become the adjacent side, and given center O to external point that is OQ is equals to 25 centimeters. Now we know by Pythagoras theorem we are going to do, what is Pythagoras theorem? Hypotenuse square is equal to opposite whole square plus adjacent whole square. What is hypotenuse value? We already know. Yes, 25 centimeter whole square. This is the hypotenuse, this is the opposite, and this one is the adjacent side, is equal to opposite side is 24 centimeter whole square plus adjacent is OT whole square. Now 25 means 625 centimeter square is equals to 576 centimeter square plus OT we are taking as radius. OT is equal to R. R means radius of a circle. Now see, bring it to left hand side. R square is equal to 625 centimeter square minus 576 centimeter square. R square we are getting 49 centimeter square. When square goes to right hand side becomes 49 centimeter square. R value will become 7 centimeter. What is the radius of the circle? Radius of the circle is 7 centimeters. We got radius of the circle is 7 centimeters. Now we are having the one more second question, which is very important, very important really. See the second question what is given. See carefully. In the figure is given that TP and TQ are the two tangents are equal with the center of the circle, so that angle POQ is equals to 90 degrees. Now then angle PTQ we have to find out how much. P, T and Q value how much you have to find out. See how I am writing this one. So we try to do as easy as possible. Now see, this is the circle and this one is the radii. These two will become the radii. Okay, so this is the straight we are going, and this is the perpendicular line P, T, O and Q. Already this value is given 110 degrees. Now if you observe carefully what is given, angle POT is given as 110 degrees. But according to right angle triangle, see, when the tangent and a radius, when tangent and radius will forms a perpendicular line. Will forms a perpendicular line. That means angle OPT is 90 degrees. Angle OQT equals to 90 degrees. Now if we see this one, 1, 2, 3 and 4 lines. When you are joining the 4 lines, which makes a quadrilateral. Here TPOQ is a quadrilateral. I think in the test notebook we written in the notes we have written in another method. You can use this method also compulsory. Now see, what are the quadrilateral is nothing but angle, two angles, angle PTQ plus angle POQ is equals to 180 degrees. Angle PT, you have to find out angle PTQ. If you make PTQ one angle, POQ another angle, so plus 110 degrees is equals to 180 degrees. Take to right hand side. Angle PTQ is equals to 180 degrees minus 110 degrees. Angle PTQ is equal to 70 degrees. Or otherwise you can write like this also, still in the method. If you take quadrilateral, 4 angles, if you want to take angle P plus angle O plus angle Q plus angle T is equal to 360 degrees. Or you can take like this also, angle P how much, 90 degrees plus 110 degrees plus 90 degrees. Angle T means what we can write, angle PTQ is equal to 360 degrees. So 200, 290 degrees plus angle PTQ equals to 360 degrees. Take this one to right hand side. Angle PTQ equals to 360 degrees minus 290 degrees, which is equals to 70 degrees. Either you do that method, or if you do this method, both you are going to get the same answer. But whether it is a quadrilateral or not, that we have to check once. If it is a quadrilateral, then we can solve all the problems easy method. That's so. Now we are going to go for the next problem. Now how we did this problem, now we are going to show next problem in the same method. We have to find out angle POA, and that mid angle we have to find out how much it is. Yes. Now see the next question. See the next question, everyone. If tangents PA and PB, now see the diagram here. See the tangents P and PB from a point P to the circle with center O inclined at each other at an angle of 80 degrees. We have to find out angle POA is equals to how much. Now see the figure carefully, everyone. See the figure. This is the figure. Okay, there what we have wrote. Now I will explain this one problem here only. See carefully. See what is given. In triangle POA and POB, when you compare two triangles, the common line is OP. OP is equals to OP, which is a common line. Angle PAO and PBO, which is equals to 90 degrees. OA is equals to OB. Why? Because both are radius of the same circle. Next, PA is equals to PB. Why? Because length of the tangents drawn from an external point are equal. That sentence we have to write. Length of the tangent drawn from an external points are equal. So finally, by we are having two sides and one angle. Angle POA is congruent to POB by side angle side congruence. Side means see, PA is one side, PB is OA is equals to OB. This is one side, PA is equals to PB. One side, angle PBO and PAO equal becomes 90 degrees. Now see what they have given lastly. Triangle APO is equals to AP. So what is APO? How we will write? Half into 1 by 2. Half into angle APB. APO. How we will write? APO. Base into half of APB. Next, half into 80, you'll get 40 degrees. So how are you going to find out the POA value? Angle APO plus angle POA plus OAP, which makes a triangle. Okay, here we are making a triangle. PAO plus AOP plus POA is equals to 180 degrees. We know already APO value is how much? 40 degrees. POA value is POA value we have to find out. OAP value is 90 degrees. So without doing also you can do calculation. POA equals to 90 plus 40 is 130. 130 take to right hand side. 180 minus 50 is 180 minus 30 is 150 degrees. If you want, I'll explain in the notebook also. See, once I'll explain the notebook. In triangle PO and POB, that is the same diagram. I'll zoom the diagram now. Okay, I'll show the diagram here. Yes, next you see the triangle. In triangle POA and POB, PA is equal to PB, PA equals to pi by tangents from the same point. From the external point, tangents are crossing. Next, OP is equal to OP, which is a common side. Angle A equals to angle B, which is 90 degrees. By right hand side, triangle POA is congruent to POB. Now see what is given still. Look here. See, if I am taking angle A equals to angle B by Cbse, angle A plus angle B, angle A plus angle B, if I am taking as both sides as 80 degrees, see already we wrote by Cbse angle A is equal to angle B. So angle A plus angle A equals to 80 degrees, 2 angle A equals to 40 degrees. Why? Because 2 ones are 2 40s, angle A equals to 40. Angle A plus angle B, we got 40 plus 40. Now by using the triangle angle A plus angle POA. See, here is perpendicular line, there you got A value. 90 plus 40 is 130, take right hand side, 180 minus 130, you are getting the angle 50 degrees. Now we are having some of the important theorems, some of the very important theorems. See, this one problem, fourth and fifth I will explain in the notebook only. Please do concentrate right over here. See, listen here what I have done. Prove that the tangent drawn at an ends of a diameter of a circle are parallel. Very simple. See, two are there. Let me finish these two theorems. Remaining fourth and fifth now I will explain. Remaining I will explain tomorrow morning. Okay. See, prove that tangents drawn at the ends of a diameter. At the diameter end, we are drawing two tangents, that we have to show that both are parallel. Now see, this is a circle and this is the diameter. this is center of the point I am taking a. Here we are joining a tangent, here also we are joining the tangent, that is called as point A and B. Now see what we are going to do. That one only is going to see tangents drawn at the ends of a diameter of a circle. See, we are drawing the two tangents at the end of the diameter, that we have to show that these two lines are parallel. So I am taking this point as PQ and R. Yes, now see here which makes a right angle triangle. Why? Because perpendicular, and here also perpendicular. Why? Because the radius and tangent both are perpendicular to each other. Now see what I am doing to given that proof I am doing. Given that PQ and RS are the PQ and RS are the two tangents of a circle touches at the diameter points A and B. Now what is OA, which is perpendicular to OB which is perpendicular to RS. If you are going to show anyone, remaining will be equal. Now see, why? Because OA is perpendicular to PQ, OB perpendicular. Why? Because these are radii perpendicular to tangent. Why we are writing radii means, see, OB is one radius, OA is one radius, so which is perpendicular to PQ tangent. AO and OB is the another two radius which is perpendicular to the tangent R and S. Now see, in triangle PAO I am taking. So if you're drawing the line like this, see from the center of the point, if I passes like this, in triangle PAO and triangle SPAO and SBOC, SB and OC, PA and O, SB and O. These are the two right angle triangles I am doing to comparison now. See, angle PAO is equal to angle SBO is equal to 90 degrees. Each how much? 90 degrees. Angle PAO is equal to angle POA. Angle PAO or POA. Angle POA and SOB POA both are alternate interior angles. You can write like this also. You can write PAO is equal to angle SBO also you can write. Either you can write these two, any one point, POA or angle SOB. Now see what you got. See, 90 degrees and these two are alternate interior angles. So PQ is parallel to RS by transversal. How it is become? By transversal only, no? But what are the transversal? Generally, if two lines are passing, if you get it like this, see these 2 points and these two are alternate interior angles. If you draw a line, see these are the two lines. If any lines by, so these two are alternate interior angle. These are alternate interior angles by transversal. By transversal, what we can write? PQ is parallel to RS. Why? Because transversal means if a line is passing through two or more lines which are parallel to the tangent. If a line is passing through two or more parallel line, that forms a tangent. PQ is parallel. So hence prove. That's it. Very simple. The circle which is having the diameter, on both the ends of the diameter we are having two tangents. Given that PQ and RS are the two tangents of a circle touches at the diameter points A and B. One OA perpendicular to PQ, OB perpendicular. Why? Because these are the two radii of the radii is perpendicular to the tangent. Now, in triangle POA and SBO, PAO SBO is equals to 90 degrees. Equals to each 90 degrees. Angle POA and SOA or PAO or SBO both are alternate interior angles, where we are having alternate interior angles and 90 degrees. There PQ is parallel to RS by transversal, hence PQ is parallel to RS. Therefore, the tangent drawn from an external points of a diameter of a circle are parallel. Therefore, the tangents drawn from an external point of a diameter, the tangent drawn from an external, therefore what will write? Tangents drawn from the ends of a diameter of a circle are equal. Now see what is the next point. Now next question, which is very easy, you may get for 1 mark question like this. Prove that the perpendicular at the point of contact to the tangent to the circle passes through the center. This is theorem number 2. Just now we already proved theorem number 2, same method. Now what is I am showing here only directly, you can see here, or I'll show in the one more diagram also. Yes, see, this is the radius, OC is the radius, OD is another radius. When two radius forms a radii, we are drawing from the center of the circle to the tangent an external point, that is A. Given AB is a tangent of a circle touching at a point C. Given AB is a tangent, the radius which is touching at the circle at the point C. Now see, OC is perpendicular to OB and DC also perpendicular to AB, because see, OC is a perpendicular line tangent. This is the tangent, this is the radius, both are perpendicular. And this is the diameter and this is the tangent, both are perpendicular. OC perpendicular to AB, DC perpendicular to AB. So angle ACD is equal to 90 degrees. Angle ACO also 90 degrees. So angle ACO is equal to angle ACD. Hence the center of the point lies on the hence O lies on DC. What is going to, the perpendicular line at the point of contact to the tangent of a circle is passes through the center only. That means every point has to passes through the center only. It should not crosses from the center. So remaining problems tomorrow morning I will explain. The problem number 6, 6, 7, 8, 9, 10, 11, 12, 13. Remaining 8 problems are there. That are 8 problems I am going to explain tomorrow morning itself. So those who are new and those who are new to this channel, please do subscribe to our channel and press the bell icon so that you will not miss any of the live sessions of our videos. Those who are new to our subscribers, please do subscribe to our channel, like the video, comment the video. If you are having any friends in the 10th grade, either in the SSC or CBSE, please try to share these videos to them so that it will be useful for them also getting good, scoring good marks in the examination. Okay, this is Indranil signing off today. So happy Sunday.